All right, well, let's get started. We're going to be talking about parallel lines cut by a transversal and equations and slopes between parallel and perpendicular lines. Okay, and now we're going to use these questions as launching points to get more information so that you can be successful on the whole topic. And these are the IXL numbers right on the side there. So let's get started. In the cube shown below, which lines are intersecting? So intersecting means they cross, right? So if we look at NO and OP, I'm going to go ahead and highlight those. Noticing that they have two letters in the name and a little line above, not one letter, not three letters, but the two. That's important. So there they are, and they are intersecting. Okay. Uh-oh. All right. So these two lines are intersecting, but now we're going to see some other pairs that we also want to know. So PT and RS. Let's go ahead and highlight PT and RS. And you can see that they are not intersecting, but one is going up and down, and one is kind of going front to back. These are called skew lines, and they are in different planes. A plane is like a 2D surface, right? Like a sheet of paper would be, example, a model of a plane. All right, so those are skew. Now, QR and OP. QR is up here. OP is down here, PO. And you can see, you might say, are those skew as well? Because they don't look like they're in the same plane, but you notice they are going kind of in the same directions here, right? And actually they are parallel. Even though there's not a plane drawn, we could draw one by just adding a couple of lines here. And you can see now, it's just a sheet of paper kind of cutting through the cube. So these are parallel. My favorite. And they are in the same plane. All right, now let's look at OS. OS. Right back there. And QT. What do you think? I think they're skew. So those are the three types of lines there. All right. Moving on. So now these lines here are called parallel lines cut by a transversal. So I think you probably see that, well, it says it there too, but these lines are parallel, and so usually parallel lines we put little arrows. That's the symbol to show that they are parallel. And this guy right here is called the transversal. It goes across the two lines, intersects them both, and it makes 8 angles. So we have all these different types of angle pairs. So bear with me and please write this down. Okay, I'm going to give you one example of each. We have corresponding angles. We have alternate interior angles. We have alternate exterior angles. We have same side interior angles, and we have same side exterior angles. And so yeah, we got the 5 there. And of course, like the question says, vertical angles, and we're also going to have linear pairs. So lots of different angle relationships going on here, and because the lines are parallel, that means all of these are either going to be, they're going to fit into two categories. They're either going to be the same, congruent, or supplementary. And I always write subs when I talk about supplementary. You remember, what's up? That's the two angles that add to 180 degrees. This sign right here means congruent, and that means the same. All right, so I also want to show you the abbreviation. So corresponding angles, I always write CA, corresponding angles. Alternate interior angles, all right, AIA. Alternate exterior would be AEA. Vertical angles, I do usually say VA. Same side interior, obviously that's SSI. Same side exterior, SSE. And linear pairs, I do write LPs. Okay, so you'll see that in textbooks as well. So what I want to do right now is just name a pair of each. So corresponding angles, I think of as corresponding angles because they're in the same corner. Like these two are in the top left corner. This angle would be PNM. So one pair of corresponding would be angle PNM, and another, and this one would be NKJ. NKJ. Now we're going to change up the colors here. So alternate interior. That is, so this is the interior. So the alternate interior would be on opposite sides of the transversal and the interior. So this one would be MNK. So angle MNK. And then this one is LKN. Angle LKN. Alternate exterior. All right. Now the exterior is out there, not inside the transversal. So let's do this one here. IKL, and then an alternate one would be, oh, well, we already did this one, but we're going to do it again. Right here. These are alternate exterior angles. Angle IKL, and what was this one again? PNM. All right. Same side interior angles are going to be in the interior on the same side. Okay. So M and now I'm losing I can't see my letters anymore, but this one would be angle M and what is that there? That, well, that's the same. It's a K, MNK, and MNK, and I'm talking about this angle right here. And the same side with that one would be here. It'd be JKN. Angle JKN. All right, same side exterior. So that's same side interior. And same side exterior would be, okay, well, we can see over here, these would be same side exterior. So PNO, angle PNO, and angle IKL. I think that's a K. IKL. Okay. So now that's enough of the three letters. I think you get the idea. I also want to show you the shortcut I love for vertical angles. So let's call this angle 1 and this angle 2. So sometimes you just put a number and then you can name the angles with the number. Just don't get confused with the degree measure, because that's not 1 degree. So, but these are vertical angles and they are congruent. Now I'm going to name this angle 3 and this angle 4 here. Angle 3 and angle 4 together are adjacent angles whose non-common sides form a line. They are a linear pair. So angle 3 and angle 4. All right, so now I'm going to, in black, circle all the angle pairs that are congruent when the lines are parallel. The corresponding angles are congruent when the lines are parallel. The alternate interior, the alternate exterior, and the vertical. Look at that. All those are congruent when the lines are parallel. And I'm going to circle in purple the supplementary ones. So same side interior, supplementary. Same side exterior, supplementary. That means they add to 180. And linear pairs, of course, are supplementary. All right. So that's a little overview. We'll be practicing that. But now we can use all that knowledge to figure out angle measures. So QRU is right here, and that's 135, huh? Well, that means that this is 135 vertical angles. But then corresponding angles means this is 135 if these lines are parallel. And it says that they are. But if this is 135, then this is 135 because they're vertical angles. And then we know that we have linear pairs that add up to 180. So this must be 45, so that they would add up to 180. So that makes this 45, and this is 45, and this is 45. So once you know that the lines are parallel, you can easily tell all the angles. So have fun with that. Now on to, let's switch gears a little bit. Talk about parallel and perpendicular linear equations. All right. The equation of line T is y equals -2/7 x plus 4/9. Line U is perpendicular to line T. What is the slope of line U? Oh, this is fun. This, I get to say my favorite word here. You want to know my favorite word? Flopposite. Flopposite. You don't hear that one outside of my classroom. Usually people use the precise vocabulary of opposite reciprocals. All right, so when lines are perpendicular, they're perpendicular. The slopes are, opposite reciprocals. That is the relationship between two lines whose slopes are perpendicular. Okay, so the slopes are opposite reciprocals, and I say flopposite. And you'll see that in just a second. But also you should know parallel lines, they have the same slope. Okay, so we got opposite reciprocals or the same. So you got to know what the slope is here. So when you look at this, do you know what the slope is? Hopefully you're saying the slope is -2/7. So let's flip it and change the sign. The slope of a line perpendicular would be 7/2, positive. Flipped and opposite, it is flopposite. All right, moving on. Line G has an equation of y equals -1/2 x plus 10. Perpendicular to line G is line H, which passes through the point -7, -9. What is the equation of line H? All right, well, first thing we want to do is what is the slope of line H? Well, I know what the slope is. The slope, we're going to start with -1/2, which is the slope of line G, and we're going to flip it, and we're going to change the sign. So the slope of line H is, this is the G slope, and so this is the slope of line H. Okay, 2. Basically, 2 over 1 is 2. So that's the slope. So now we can write y equals 2x plus b. We know that line H has a slope of 2. So we know that it's 2x. But now we need to know the y-intercept. But that's okay. We can do that because we know one of the points on line H. So we're going to substitute that in. -9 equals 2 times -7 plus b, and then solve. -14 equals 9 plus b. Add 14 to both sides. Oh, I think that's 5. Okay, so b is 5, and I know my slope is 2. So the equation of this guy is going to be y equals 2x plus 5. All right. Thank you for watching. Please post your comments below the video in the Google Classroom, and I will see you in class.